This is the first video on consumer theory called Consumer Theory 1. And what we're going to do here is lay out some definitions and some terminology and some notation so that we can then show you more of the mathematics of how to solve the standard consumer theory problem. The standard consumer theory problem goes something like this. Consumers can buy lots of goods, and they have to decide, given the income that they have and the prices they have to pay for the goods, what's the best, that is, the utility maximizing quantities of the goods to buy. And so we're going to use a notation and examples from problems in microeconomics. You can check that out or keep it side by side as we go through this. T is the quantity of tacos, so we're going to be assuming that there are two goods that the consumers can buy, so we can use two-dimensional graphs to convey almost everything. S is the quantity of spaghetti, so the consumer wants to find out the quantities of tacos and spaghetti to buy. I is the consumer's income per unit time, per week, or per month. P subscript T, PT, is the price of tacos. PS is the price of spaghetti. And U denotes the value of utility in the utility function. So the utility function is usually written something like this. The utility function, make that a little narrower, we can write as a function of the quantity of tacos and the quantity of spaghetti. The thing called an indifference curve, which is defined as all the points relating S and T that have utility being a fixed value. An indifference curve for a level of utility U bar is the implicit function between the quantities of S and T that the consumers can buy. So there may be another indifference curve here, for example, and that would correspond to the utility level U bar. So it's a function of T on the vertical axis and S on the horizontal axis. These aren't dependent and independent variables here because this is an implicit function. With this in mind, then we can define the thing called marginal utility. Let's write it a little bit differently. So it'll be the change in F with respect to T is what's called the marginal utility of tacos. We can go up here and show you the partial derivative of F with respect to S. That's the marginal utility of spaghetti. It's the extra utility you get when you have a very small increase in the quantity of spaghetti. Following on then with additional definitions, we define something called the marginal rate of substitution of S for T, of spaghetti for tacos, and that's equal to, it's defined as minus the change in tacos, these are total differentials, divided by the change in spaghetti, given that U, utility, is a constant, or another way to say that is du, the differential of U, is equal to 0. Now it turns out that you can express the marginal rate of substitution of S for T in terms of marginal utilities. And the way you do that is you simply find the total differential for the utility function. That's the differential of U, which we know from the definition of the total differential, is equal to the partial derivative of the function with respect to S plus the partial derivative of the, we want to add ds here, and the partial derivative of F with respect to T multiplied times dt. So we have a little caret insert here to get that ds in the equation. So for du equal to 0, we have 0 must be equal to the marginal utility of S ds plus the marginal utility of T dt. And you can do a little arithmetic on this equation here and find the marginal rate of substitution, which is this big thing here. And you'll see that the marginal rate of substitution, dt over ds, is equal to the marginal utility of spaghetti divided by the marginal utility of tacos. So the marginal rate of substitution, the slope of the indifference curve, in absolute terms, is equal to the ratio of the marginal utilities of the goods as we've specified them here. The last piece that we need to get straight is the income constraint, which defines the relationship between income and the amount spent on the goods. So income can't exceed plus PTT. PS times S is spending on spaghetti, PT times T is spending on tacos, and that has to be less than or equal to income. And we can then show you what this income constraint looks like by rewriting it so that T is equal to income over PT minus PS over PT times S. For given values of income and the prices of the two goods, PS and PT, T, the quantity of tacos you can buy, is a linear function of the quantity of spaghetti that you buy. And the intercept on that income constraint is income divided by the price of tacos. So we can draw that here. This is I divided by PT. And this is a straight line. And this intercept here is income divided by the price of spaghetti. And so what we're looking for is the indifference curve that represents the highest value of utility that we can find. And we'll show you what that is here with a nice red. So I'm looking for the indifference curve that just touches the budget constraint so that U star would be the highest value of utility. So now what we want to do is move on to the mathematics as opposed to the graphical representation of finding this answer. And so in the next video, we're going to turn to a theorem called the Lagrangian theorem, which isn't much noticed in mathematics, but in economics it turns out to be huge because it's the key to solving all of the constrained optimization problems that we encounter, such as in consumer theory, cost theory, and in perfectly competitive markets that need to be solved as part of a microeconomics course.